Hello, good afternoon to everybody, and welcome to all the participants for the second session of day one, the in the FDP of sustainability in the textile industry. Basically, today's speaker, which is with us, is Professor Prashanta Panda. He is very experienced person. I will just go through his bio scale. He's a senior scientist at the Bombay Textile Research Association. His office is in Ghatkopar West, Mumbai. He is, I think, oldest textile research association. As textile industry started from Bombay itself, as said by the previous speaker, Professor Kothari. He completed his MTech and after that PhD in fiber science and engineering at IIT Delhi. He is having a blend of experience of textile industry, then academia, and as well as the research. So he is the right person to discuss the things with academic people because he's having a textile and research experience and academic itself. So what is the requirement in academia, he will know, he is aware of very well. Then he's having a good number of publications in international and national journal of repute, as well as in national and international conferences. His research area and expertise is in functional fiber, plasma finishing, and nanospacing. With this small demo explanation of the speaker, information about the speaker, I hand over I request Professor Panda sir to start his lecture. 1 minute, sir. I will make you presenter, and then you can start the lecture. Sir, you can share your screen now.
It's not showing, sir. Can you send once?
Sir, your screen is seen. You just open the PPTs. You can open the PPTs.
Okay.
The screen is visible. Yeah, your PPTs are visible. Yeah, advances in blow room line.
Yes.
Before the start of our presentation, we can have whether voice of presenter or speaker is audible or not.
Yes.
Please participate in the poll. Please participate in the poll so that we come to know that voice is audible. If anybody is having a problem in giving the vote, then just minimize the screen and again make it full screen. Yeah, around there's going to be 90% says that yes, 15% says no, Please vote fast, be fast, so that we will come to know that there is no issue related to the audio. And if somebody is facing the problem related to the audio, please check your audio system from the menu. As already discussed, right top corner, three dots are there. From that, you change your audio setting and again set appropriately. Otherwise, you leave the meeting and rejoin it. Next 30 seconds, we'll have the vote and then we'll close the vote. Be please fast. Share your vote. Be fast. If you are still not voting, there are around 70, 80, 75% voters. 30% people are not still voted. Please be fast. So around 90% people says that there is no problem with audio. Few of those who are having a problem, please tell us, write down in the question box or what I already told you. Rejoin again. You leave the meeting and rejoin again. Panda sir, you can start your lecture.
Yes. Your screen is coming over the slides.
1 minute, sir. What screen is seen?
Your video screen is showing over the slides.
Sir, video screen can be shifted anywhere you want.
There is a minimize button. There was a minimize button, I think, that day. Yes. Yes, I have shifted it.
Okay.
Okay, sir. Shall I start?
Yes, sir. You can go ahead.
Yes. Good evening to all participants, and Mukund sir, for your warm welcome for this session of this Green and Sustainability in Textile Industry Faculty Development Program. I hope all participants you are well and fine in this pandemic. And today's topic that I will go to explain introduction of fiber and yarn and the advances for energy reduction. So it is most of the participants that I know is from the other backgrounds, and those who are from the textile backgrounds, they know everything about this. First of all, to make aware that what is textile, what is fiber, and how the yarn spinning the process, and that is I will give a brief description about some yarn spinning processes and different fibers available and what are the advances have been made in this sector. Sir, slides are not changing. Hello.
Yes, sir. You just move with the keyboard.
My keyboard also that day it was moving, but today I don't know. Can I minimize it?
Yeah.
It is not also minimizing.
It is okay, sir. Now it is.
Yes.
Yeah.
So textile processes, if you see the textile processes is a long process to make the fabric for the end use application. That is fiber production, yarn production, fabric production, and post treatment, that is dyeing and finishing. Then this fabric can be used for the apparel or technical sectors, depending upon the quality of the fabric. So if we'll see what is fiber. So we know that fiber is a smallest constituent of the fabric. Whatever the fabric we are using, whatever it may be for apparel, for hosiery, for technical textiles, these are made from the smallest unit, that is fibers. So different fibers have different properties. So we have to select the fiber what for you are using this. And they have the high L by D ratio. L by D means length by diameter. Means diameter is very small compared to the length. It should be at least 100. So you will see the classification of textile fiber. So textile fibers mainly classified in natural and man-made. Among the natural, that is also divided into three categories. One is cellulose base, protein base, and mineral base. So cellulose based fibers are bast. If we will see collected from the stem of the plant, so it is the bast fiber, that is flax, hemp, jute, and ramin. The flax we know linen. Today we are telling that linen is the flax group of fiber, and the fibers which we are collecting from leaf, that is manila and sisal, and the fibers which we are collecting from the seed, those are cotton and kapak. These are the seed fiber, leaf fiber, and bast fiber. This is cellulosic fiber. And protein is a animal fiber. It is a constituent, its chemical composition is proteins. Different proteins are there. So it is a maybe staple camel, cashmere, lamb, mohair. It is wool is the staple protein fiber, and sheep wool is there, and filament protein fiber is the silk. Silk is the made up of two proteins, that fibrin and sericin, secreted from the silkworm, and the mineral fiber is the asbestos, which we are getting from the mines. And another group of fiber is the man-made. Man-made is again divided into organic and inorganic. So organic is again natural polymer base and synthetic polymer base. So natural polymer means where the polymer we are getting it from the natures. That is cellulose base, that is rayon. Rayon fiber is the regenerated natural fiber, which is we are making it from the wood pulp or cellulose getting from the plants. Then protein base is Asian fibers. So these are the made from the proteins available, the soya protein, milk protein. So these proteins can be converted into the fiber artificially. Then alginate and rubber. So these are the natural polymer based man-made fiber. And another group is the synthetic polymer. Synthetic means all we are making it from the man-made sources, that is petroleum sources. We are making the fibers. Those are synthetic polymer base. That is acrylic, aramids, fluorocarbon, monoacrylic, nylon, polyester, olefin, that is polypropylene, polyethylene, and many more, spandex. And another is the inorganic man-made fiber, that is glass, metallic, or specialty fibers. So glass fiber also we are using for different technical applications. These are the inorganic man-made fibers. First up, we'll do the natural seed fiber, which is cotton. So everybody know about the cotton. It is not accepted fiber among us. That is, in undegraded cotton fiber, DP is higher than 20,000. That is monomeric D-glucopyranosyl units. That is, DP is degree of polymerization. Degree of polymerization means the number of repeat units present in the polymer. So in viscose, what is the man-made regenerated fiber? That is, DP is degree of polymerization is 300 to 500 only. Here we can see, you can see the structure of this cellulosic polymer cotton. It is, the DP is 20,000. So if we will see the cross section of the cotton fiber and one bast fiber, you can see here, and that is, this one is the cotton fiber, this top left corner, it is the cross section of the matured dry cotton fiber, and you can see this lumen is a hollow structure in between the fibers, and this is the longitudinal section, this is the cross section, and this is a moisturized cotton, means it treated with the sodium hydroxide. You can see that circularity is increased from this dry fiber, so it gives you some better lustrous appearance after the treatment, and it is one bast fiber. This is the cross section and this is the longitudinal. Bast fiber means we are collecting from the stem of the fiber, stem of the plant, that is jute, flax and others. And here you can see this is the synthetic fiber, polyester low modification ratio trilobal. This is the polyester cross section, that is trilobal, means its 3 lobes are there, and it has been made artificially, and this is the rayon cupranium ammonium rayon, and this is the viscose rayon, the regular rayon that we are using for the apparel purposes, and this is the cross section of that fiber. And this is the sectional and longitudinal view of the polyester. You can see that polyester is a very rod-like structure and smooth structure of the surface, and it is a cylindrical, and we can change the shape, cross-section shape also by changing the machinery parts. So what are the different properties of the fibers that we are using to making the fabric? And that one is the microscopic properties, chemical properties, physical properties and biological properties. So these properties are responsible for suitability of particular fibers for specified end use. These properties decides where we can use this fiber and what type of fabric we can make and where we can use it. Some of the properties are essential to be used as textile fiber, whereas some properties are desirable but no essentiality. So one main property, that effect of sunlight. So you can see that there are different fibers, that is acrylic, deniel, nylon, cotton, acetate, rayon. These are natural fiber. Cotton is there, some synthetic group of fiber are there. You can see that is the loss in tenacity percentage, and after 200 hours of exposure to direct sunlight. So acrylic is very low loss in tenacity, and rayon is high loss in tenacity. It depends upon the different polymeric structure of the fiber. So what are the essential properties of textile fiber? Should be, that is length to breadth ratio, it should be at least 100 for the use as a textile material. Cohesiveness or spinning quality, if there will be no cohesiveness between the fibers, we can't spin it, because human hair we can't spin to the yarn, because there is no cohesion between the hairs. And the strength is essential for the end use application. Flexibility, it should be flexible to be spin but to apply the twist to keep it together, and uniformity. So uniformity is also essential properties. If there will be no uniformity of the fiber, we can't get a uniform yarn out of it. So if we will describe this as length to breadth ratio, a minimum ratio of 100 is usually considered essential. Cohesiveness can be defined as the ability of fibers to stick together in yarn manufacturing processes. This is important for yarn making. If it will not stick, it will split up during the yarn processing. We can't gather and we can't apply twist to them to make a continuous yarn. Strength of fiber decides behavior of fibers during processing, properties of end products. First of all, where is the fabric meeting में so where we are using the fabric, that we have to there should be some strength of that fabric. So strength of fiber decides so how it will be processed. During the processing also there is a requirement of strength, and it is one of the most important properties of the fiber. A minimum fiber tenacity of approximately 2.5 GPD. GPD means gram per denier is desired. Denier is one unit of the yarn measuring. I will describe it later. Flexibility and pliability. The yarns and fabrics should possess certain qualities: ability to drape, flexibility, and low bending length. Low bending length means in a low short length it should bend due to its own weight. And ability to drape means hanging property, sagging property. If we hold a paper at a certain point, it will not, if we hold a fabric, you will find that fabric is sagging more than the paper. That is the drapeability of the fabric. If a net nylon fabric is there and if one cotton fabric is there, so drapeability of the both of the fabric will be different. Where the drapeability is more, the flexibility of fabric is more. Therefore, the fibers should be flexible and pliable for the making yarn and fabric out of it. So, uniformity in order to manufacture good quality yarns and fabrics, it is important that the fibers should be similar in length and diameter, spinning quality and flexibility. So, length and diameter, it will be similar. Otherwise, if dissimilar, there will be no matching of the property of the fibers and it will not give you a uniform yarn. The secondary property, those are desirable properties. So we see as it is the physical shape, specific gravity, luster, moisture regain, elastic recovery, elongation, resilience, thermal behavior, resistance to biological organisms, resistance to chemical and other environmental conditions. The shape of the fiber is responsible for certain different in yarn and fabric properties. Suppose shape is also decides the fiber shape will decide the yarn shape and its behavior also change. Suppose a trilobal and circular. If it is circular, if we will make yarn out of it. If it is trilobal and we will make a yarn out of it, there will be a difference in the lusterness of the yarn due to the reflection behavior of the fiber as well as the yarn. The luster refers to the gloss or shine that fiber possesses. It determines the fiber's natural brightness or dullness. How is the fiber? It is brighter or dull. So silk is high luster and cotton is low luster, and man-made fibers luster can be controlled. By changing the shape, we can change the lusterness of the fiber as well as by changing in the polymer, and we can change the lusterness of the fiber. The specific gravity is if it is specific gravity of the fiber is more, it will be the heavier fabric compared to the fabric made out of the lower specific gravity fibers. The fiber cotton having the 1.54, polyester 1.38, nylon 1.14, viscose 1.52, and polypropylene is 0.91. So that polypropylene floats on the water because its specific gravity is below 1. Moisture regain is the weight of water present in the material fiber expressed as percentage of the oven dry weight. It will express it the water content of the fabric percentage in the percentage respect to the oven dry weight of the fabric. So it is the moisture regain. So elastic recovery, how the fiber yarn recovers from the deformation. And elongation, breaking elongation gives a measure of resistance of the material towards the stretching. How it resists to the stretch force. So resilience is the ability of fiber to bounce back or return to the shape following compression, bending or similar deformation. After bending or deformation, how it coming to the original shape. Thermal behavior includes conductivity, specific heat, coefficient of thermal expansion, melting point, latent heat of the melting, etc. Different thermal behavior of the fiber also decides the thermal behavior of the fabric. Resistance to biological organisms. The behavior of the fibers towards insects, molds, bacteria and fungi. We know that the cotton is very prone to this biological attack than the synthetics. Very natural fibers. Many natural fibers are prone to attack by the biological organisms. So resistance to chemicals and other environmental conditions. All fibers differ in their chemical structure. Their resistance to acid. Due to this difference in chemical structure, so their resistance to acids, alkalis, bleaching agents, dyes and other chemicals also differ. So if you see common terms and definitions in fiber, the natural fibers that occur in fiber form in nature. Man-made fibers artificially prepared from the chemicals. Thermoplastic fibers those soften with heat and thus become pliable, and we can change the shape of it and we can convert it into the shape. So non-thermoplastic fibers that don't soften or melt with heat degrades and lose the property at a high temperature. So non-thermoplastic is thermosetting. We can change, we can melt it and we can change the shape of it. And staple fibers are short length of fibers. This may vary in length from half inch for shortest usable cotton to 18 to 30 inches in long linen fibers. So it can vary half inch to the 18 to 30 inches. That is the staple fibers. The short fibers we will make the yarn out of it by using the different yarn spinning processes. Filament fibers. Filaments are continuous long length from 400 to 1300 yards or more. Tow refers to the short fibers removed in processing flax and also the multiple filament strands of man-made fibers that are cut or broken into short lengths for spinning into spun yarns. Thus, long length filaments can be cut and spun into the yarns. So these are the tow conversion of the filament to tow conversion. So few properties of natural fibers that good properties that hydrophilic in nature, comfortable, high moisture regain. Due to all these properties, natural fibers are mainly cotton, silk and wool, most and well accepted by us. So high moisture regain, comfortable and hydrophilic in nature. So you will see that moisture regain at 65% RH, cotton having 8.5 to 10.5, flax 12, that linen fiber now we are using in the April. Wool, it is 16% moisture regain, silk 11, nylon 4 to 5, polyester we can see that 0.4 to 0.8 only, very low moisture regain. So it is for that only it do not give a comfort property during the use as apparel, 100% polyester. If we use the 100% polyester as apparel purpose, so comfort property of the polyester were very low compared to the natural fibers. So polypropylene, it is regain is almost nil, acrylic 1.3 to 1.5 only. So few unique properties of synthetic fibers which we can get in the natural fibers. So high strength and greater durability. Synthetic fibers are characterized by their higher strength and greater durability. The tensile strength for polyester, cotton and viscose are compared below. We can see here their comparison. The tensile strength we can say at polyester 4.5 to 6.5 GPD, grams per day here is a unity of the tenacity, tensile strength. Cotton, it is 2.5 to 4.5, viscose 2. You can see their polyester have the more strength than the natural fiber cotton and rayon. So better crease recovery. Synthetic fibers don't require ironing after washing. as they can easily recover from the stress and strain. So after washing the cotton fabric, we can't wear without ironing, but in synthetic fabric, there is no need of ironing after the washing. That fiber at 5% extension and recovery, we will see the nylon polyester recovering 95 to 100, cotton only 45% recovery is there. Elegant appearance, garment made from synthetic fibers look much more elegant than from natural fibers. Dimensional stability, they have very good dimensional stability after heating. Bacterial resistance also good compared to the natural fibers. So these are the some unique properties of synthetic fibers and some properties of the natural fibers which I discussed. Among these, we can select what fiber we can use for the what are the applications. The fabrics we are making, yarns we are making for what will be its application. It decides the property. First, we have to choose the fiber property. So dimensional stability, and these are the some properties which we can find in the synthetic fibers, and some property we can find in the natural fibers. So natural fibers are more comfort than the synthetic, and they are vulnerable to the biological attacks and degrades easily, and crease forms easily, recovery is less, and some properties are also comparatively less than the synthetic fibers. So if we see that man-made fiber forming process, how we are making the man-made fibers out of the polymers. So melt spinning, there is two spinning technology there, melt spinning and solution spinning. So melt spinning to produce filaments from those polymers which can be melted without thermal degradation. Nylon 6, nylon 6, polyester, polypropylene, these are some fibers which can melt it and form the fiber, and these polymers do not degrade during the melting. Melting is essential, but other criteria are there to make the polymer spinnable. Sorry, it is spinnable. Next is the solution spinning. This the purpose is to produce filament from polymer which degrade before melting or having very high melting point. So polymer which have the high melting point or otherwise it degrades during the melting, we can't spin it by the melt spinning, so we have to go for the solution spinning technology. So here it is the schematic of a melt spinning process. You can see here it is a polymer chips hopper. It is a one unit I am showing you. It is a chip, but now this unity in the plants, it is directly connected to the polymerizer. There is no hopper and there is no feeding up of polymer chips. So this polymer chips in the place of this is directly connected to the polymerizer plant. So from the polymerizer directly the polymer melt will float here, and if we are feeding the polymer chips, there is a screw. So which screw melts the polymer and the heaters are there. This screw melts the polymer and press it to the one other is metering pump. This metering pump feeds the material to the spin pack, and then it is the cooling zone of the filament, and there is the goddess, and this is the collecting package. And I will discuss one by one all these parts. So this is the extruder. Extruder is the three heaters are there, 1, 2, and 3. So the temperature of these three heaters are slowly increasing as per the melting point of the polymer that we are spinning. So here we will feed the chips by polymer here, and this is the here the polymers are in solid stage, so this space is more, and when it is converting into the molten polymer, the space is slowly decreasing, and by revolution of this screw, it feeds the polymer, molten polymer, to the feeder metering pump. In the plant, there is a manifold. Here is the one unit, but in the plant where the polymerizer is there, it feeds the polymer through the manifold to the different spinning line. Manifold is simply network of distribution pipe to feed the molten polymer from extruder to the metering pump. So here I am telling you about showing you the extruder, but in plant there is the direct polymerizer is connected to the manifold. So design in such a way that polymer takes same time to reach metering pump from extruder. In this manifold is designed to feed the molten polymer to the metering pump in the same time. And residence time of the material inside the distribution pipe should be same, and pressure drop in every channel should be same. All parameters should be same, otherwise the fiber property will be different from spinning line to spinning line. So another part is the static mixture is there. Network of channels interconnected with each other like a honeycomb structure. System takes polymer from periphery to center and from center to periphery for the uniformity in temperature on melt. To maintain the melting temperature of the polymer that flowing from flowing to the different spinning line, that should be equal. So it maintains the temperature from periphery to the center by flowing the polymer in this manner in the honeycomb structure. System includes the shear mixing. So due to this shear mixing, the temperature maintains by uniformly temperature maintains in the polymer, molten polymer before entering into the metering pump. So this is the metering pump which feeds the material to the spin pack. This molten polymer, it is a positive displacement pump, regulate throughput rate from the spin rate, delivers polymer melt at a constant rate irrespective of back pressure. Throughput rate and takeoff speed decides the denier of the filament. So here you can see two gear are there. It is the melt in. So gear will take in this way, in the peripheral way to the melt out. But this melt out from this portion, due to the pressure, the polymer can't flow back to the in position. So this is designed like this. Like this, it is a positive displacement pump. Only onward flow is there. There is no back flow. And the spin pack. So metering pump when push the material to the spin pack. Here is the chamber for the storage of the melt reservoir, you can say, and to avoid the pulsating effect of the gear metering pump. So it is the storage, and then this is the filter which filters the solid particle or agglomerated additives in the melt. And one is the distributor which distributes this molten polymer over the spin rate thoroughly. Spin rate means that conical holes are there, very tiny holes, through which the molten polymer will pass in a fine filament form, then it will be cooled. Then is the spinneret plate. It is a thick metal plate having fine holes. Holes are conical in shape and larger diameter towards inside surface. Allows polymer entry with minimum pressure drop. Conical entry facilitates the alignment of polymer chain. It is the entry point is higher diameter than the exit point. It is conical in shape. The conical entry facilitates the alignment of polymer chain. It can be for monofilament. These holes can be vary 0.5 to 1 mm, or for multifilament it is 0.5 to 0.05 mm. Next is the quenching. So we have to cool the filaments, molten hot filaments which are coming from the spinneret. So there is a mild flow of cooling air, that is 15 to 30 degrees Celsius, which low to moderate relative humidity takes heat of spun filament and facilitate the solidification of the polymer. Uniformity in airflow is important to avoid the variation of diameter. Airflow should be uniform. Three types of airflow there is cross flow, outflow and inflow. That is the cross flow, this is the outflow, this is the inflow. So maximum use is the cross flow. So it is the uniform flow is there. So cross flow, many plants are using the cross flow technique. Next is the spin finish application. Then after this cooling, we have to apply the spin finish. So spin finish is a lubrication between the yarn to facilitate the lubrication between yarn and metal parts, because yarn will go different processes after the spinning. So it will give a lubrication effect and allow dissipation of static charge generated on the fiber, improves cohesion to keep the filaments of yarn together. Otherwise it will split up. Spin finish component. So it is a lubricant. Spin finish. These are different components. The spin finish. One is lubricant, anti-static agent, emulsifier, antioxidants, antibacterial, corrosion inhibitor, deformers, and others are there as per the requirement. People are set together to make the spin finish. Next is the take-up winder. Then after this cooling and spin finish application, we have to collect in a package. It winds the filament to bobbin. It can be attached directly or after drawing process. That is the spin drum. It may be friction type or direct driven. This is a friction drive. This is a direct driven. So direct driven, the tension increases due to the increase in circumference. But in friction, there is no problem. That problem is not there. So here the mechanism should be there. With increase in diameter of the bobbin, that tension should be reduced, but more feeding will be there. Next is the drawing of the filament. So these filaments which we prepared from this molten polymer, they are in amorphous structure. So we have to draw it, stretch it to get a form the crystal structure and to achieve get the strength in the filament. Here I will take it plot this strength, stress grams per denier and elongation of this filament. We can see there is no increase in stress, but elongation is there. This is the natural draw ratio of the polymer, and after that there is the increase in stress, but it sustains it takes stress for the elongation. So this is total is the maximum draw ratio. This is the MDI. This draw ratio we can apply to make the filament stronger. And you will see this is the amorphous region. These polymer chains are randomly arranged in a manner. Here the semi-crystalline, some close structure are there, crystal formation is there in the polymer, which gives the strength to the filament, man-made filament. These some gaps are there. This is the amorphous region and these are the crystal region. So it is known as the semi-crystalline. The fiber is a semi-crystalline in nature. And here they are after drawing how these are arranging. These are the amorphous, the polymer chains are randomly arranged. Here is some portions are well arranged to form the crystals. This is the molecular orientation during drawing. It is very necessary after the spinning. So why the necessity of drawing? To remove the region of natural draw ratio. And beyond this natural draw ratio, polymer forms elastic network extends along the direction of fiber axis. This gives fiber high strength, initial modulus, yield point, and recovery. So these are the some filament structure. This is LOI, low oriented yarn. The slow spinning speed. If the spinning speed is slow, 1000 to 1500 meters per minute, so it forms the low oriented yarn. That is extensibility is very high. In the partially oriented yarn, spinning speed is 3000 to 4500 per minute. So extensibility is 70 to 90%. In fully oriented yarn by FDY, fully drawn yarn, the spinning speed is above 6000 meters per minute and extensibility is 10%. This is the suitable for the making the yarn out of it. So now LOI, nobody are preparing the LOI. The POI is partially oriented yarn that the people are preparing for the text, making the textured yarn. This is how you can see that orientation. This is the textile fiber, that is the industrial fiber, where the orientation is very high in case of industrial fiber to make it stronger, which is required for the end use application. And here in the textile fiber, there is no so strong is as much strength is required that can be achieved by this type of orientation. So you will see that birefringency of the fiber, that is the refractive index of parallel to axis minus perpendicular to axis. The polyester birefringency is 0.188, means it is parallel to axis, it is well arranged, oriented to the respect to the parallel to the axis. So drawing instability means if setting material is non-uniform, then after drawing this will increase, and the drawing parameter also creates the drawing instability, that is drawing tension, fiber morphology, higher load ratio. Machine eccentricity in machine parts, improper speed, improper drawing also can affect the create the drawing instability and affect the property of the filament. Next requirement is the heat setting. Then we have to heat set the fiber and to relax it at a condition that it will not shrink or deform during the processes at that temperature, 1 year that temperature. There is 3 types of setting is there. Temporary setting, that is setting at a glass transition temperature and cooling. Semi-permanent setting, setting at higher than the glass transition and cooling. And permanent setting is the partial melting and recrystallization. So based on the application, we have to choose what type of setting we have to apply the filament before making the material. Then this is the plant of polyester staple fiber spinning line. This is the filaments, it is the collecting rollers, spin finish application, draw rollers, stem box, heat setting, cooling, then reheat, stopper box, crimping. Some crimps will be applied to the fiber to make it cohesive, and then it is the staple cutter and belling. After cutting, we have to make the bell and send it to the industry for the making of yarn. It is the staple fiber, the filament conversion to the staple. In the filament, fiber is forming in the long length. Then to mix it with the cotton by blending with some natural fiber, as the natural fiber is a short length, so we have to convert it into the short staple length. Next requirement addition to the melt spinable filaments is texturizing. The process to introduce crimp, loops, coils in the continuous filament. It stabilizes the POI through heating and drawing. This is for texturized yarn. POI is necessary. So POI will be draw and texture. Texture means to make crimp, loops, coils, to make some voids in the yarn, make it comfortable, and to make the yarn fuller in nature. And these texturized yarns, nylon's texturized yarns is suitable for ladies' hosiery, and polyester texturized for apparel and households. These are some textured yarn, image of textured yarn texturized by different techniques. I am not going details to the techniques. And these are the loops that have been formed. The loop shape are different based on the mechanisms. So what are the modernization to reduce the energy consumption in the melt spinning? So high-speed multiple thread line yarn manufacturing unit. If we have to reduce the energy, then we have to make the high speed and increase the production. So that can be achieved by the replacement of batch-wise production to continuous high-speed production unit for POI and FDY, which gives 55% less energy consumption. Then multiple thread lines to increase the production. So whatever the manifold, whatever the polymerizer we have to distribute it to the multiple spinning lines to increase our production. Use of high-speed winder to produce FDY directly. High-speed winder we can use to draw the yarn directly above the 6,000 meters per minute directly to prepare the FDY. Use of energy efficient motors. Then another is the motors. It should be energy efficient to reduce the energy consumption during the melt spinning. Then reduction in high spinning hull by false sealing. Height of the spinning hull we can reduce by the false sealing, and this also reduce the energy consumption due to humidification, ventilation and air conditioning. So improving the motor efficiency in texturizing unit. The texturizing unit is there as people are using thyristor control system where heat generation, need of fan for cooling, slow speed. So now it has been replaced by the transistor inverter frequency control system to reduce the energy consumption. Next, we'll go to the solution spinning, those who are not spinnable while the melt form. So different types of solution spinning we can see: dry spinning, wet spinning, dry jet, wet spinning. Dry jet means extruded into the hot chamber. Wet spinning extruded into the coagulation bath in a liquid bath. Dry jet wet spinning extruded into air and eventually taken into the coagulation bath. That is the wet spinning. Directly it is immersed in a coagulation bath. That is the wet spinning. And in this wet spinning technology, viscose can be spun by the wet spinning technology. This is the rayon spinning line. That is, these are the cellulose seeds which we are collecting from the natural source. And it is the steeping process where we are using 18% sodium hydroxide to make it the sodium cellulose. And it is the threading, we are cutting it the seeds into the very fine pieces. Aging, we are storing it for the shortening the chain length of the natural cellulose. Then it is the xanthation, treated with the CS2 carbon disulfide to make it the sodium cellulose xanthate. Then dissolving with the NaOH. So when sodium cellulose xanthate will be dissolved by the NaOH again. After this dissolution, the filtration to filter out the agglomerated or particles present in this slurry. And is the ripening. Ripening is the regeneration, means it is redistribution of the. Here we are storing this slurry up to 1 to 3 days for a long time for the redistribution of this xanthation among and in between the cellulosic chain. Then this spinning and regeneration. Here regeneration is this conversion of this polymer solution, the cellulose solution, to again cellulose. That is acid bath. Sulfuric acid converts this into the again regenerated the cellulose in a fiber form. And sometimes the people are zinc to delay this regeneration process for the stretching and orientation of the viscose filaments. This is the stretching, and here is the cutting and finishing. Then drying and opening, and it will be bale will be prepared. Then it will be sent to the industry for the yarn spinning. So regeneration and the coagulation bath, we are using the sulfuric acid for regenerating 8 to 10%, sodium sulfate, the salting out agent for 16 to 24%, and the zinc sulfates compound formation agent for 1 to 2%. The zinc sulfate delay the regeneration process for the increase in orientation in the filament. This is the dry jet spinning method. Only hot air will be applied to dry the solvent and make the filament. This is the solution spinning, dry jet solution spinning. And here dry jet wet spinning, some time it will be in the air, then for the short time it will be the air, then it will be immersed in the coagulation bath. This is the dry jet wet spinning. The lyocell can be spun into the by using this method, and here lycra, acetate and polyacrylonitrile can be spun by this dry jet spinning method. So other different type of wet solution spinning is liquid crystal spinning. The crystal will be formed in the liquid phase, then it will be spun into the non-solvent bath. It is highly oriented structure in solidification. And gel spinning, polymer solution is kept at dilute to enable low entangled density. This helps individual chains to well connect other and coagulation forms network structure which is able to undergo hydro ratio. If it is entangled density, low entangled density, if we spun the yarn, then a hydro ratio we can achieve to orient and make it a crystal. And then another is the phase separation spinning. In the modernization, what are the modernization to reduce the energy consumption in the wet spinning? Installation of variable frequency drive motors on hot air fans in viscose drying units. So VFD motors. Use of lightweight carbon reinforced spinning pods in place of steel. That will decrease the weight of pod to the 2.8 kg to 2.2 kg. Means it is a material. So we can use the lightweight material for the different zones of the spinning line. Then installation of VFD and motors of dissolvers. So the motors which we are using the dissolving this cellulose, that also there we can use the variable frequency drive motors. and installation of lead compartment between the pots. Between the pots, we can use the lead compartment to reduce the energy consumption. Use of high pressure steam based vacuum ejectors. Use of heat exchanger in drying of viscose filament yarn. So here the lead separator. What is the lead? If it is open, the one part is here, another part is here. There is the cross parts without the comment. There is the cross of the airflow. So turbulence is there, and here if we use a separator, then there is the separation between the airflow, which reduces the energy consumption. Then these are the man-made fiber production. I discussed about the melt spinning, wet spinning, and here how the staple fiber will be converted into the yarn. That is the staple fiber yarn spinning. So there are the different processes that opening and mixing of fiber, individualization of fiber, attenuation of fibers parallel to axis, application of twist to keep them together. So if we'll see that fibers in the bell form. For the transportation, we are pressing it and making a bell, a shorter package to transport it from the manufacturing unit, from the harvesting place to the industry. So here the process starts from opening and mixing of fiber. So we have to open the fiber first and mix it. Why is mixing? Mixing means suppose we are taking the fibers from the different grades and we have to blend the fibers, natural fiber with the synthetic, then we have to mix the fiber. Then individualization of the fiber. So we have to individualize all the, separate all the fibers from the top. Then attenuation of fibers means parallel, making it parallel to the axis. Then application of twist to keep them together. Then the final is the yarn formation by application of twist. So these are the different processes. One is carded yarn, one is combed yarn. So carded yarn process is first is the mixing and opening, which the machine is blow room. Then carding, that is the individualization. Then draw frame, there is parallelization by attenuation, and draw frame 2 to increase the parallelization. Speed frame to make an intermediate product before the spinning. That is the next is the ring spinning, which applies the twist and makes the yarn. So next is the combed yarn. Combed yarn means it is one type of yarn. It is one type of yarn. Combed yarn is an optional process. Combing process is there to remove the short fibers. If we remove the short fibers and make the fiber uniform, then it will prepare a very fine uniform yarn or the hosiery application. Then it is also blow room is there for opening and mixing. Carding is there, individualization of the fiber. Draw frame, first draw frame section is for the drawing, attenuation of the fiber, parallelization of the fiber to the axis, and the lap former of the combing. So we have to make a lap for the combing, sliver lap. Then after combing, there is draw frame, second draw frame. Then next is the speed frame to make the intermediate product. Then a ring spinning to make the yarn. Apply the twist to the roving. Next, other process is the open end yarn. Open end means the rotor spinning yarn. It is the blow room, opening and mixing, carding, draw frame 1, then direct to open end spinning. So here it is the sort of process. If we shorten the process, then ultimately energy consumption will be low. Here we can see the air jet yarn, blow room is there, opening and mixing, carding is there for the individualization, draw frame 1 is there, parallelization, draw frame 2 is there to increase the parallelization, and next is the air jet spinning by the air. Here is also there is process is short, but side by side we have to see the quality of the yarn also. As per the requirement, we can use what process we have to use. For the apparel, we can take the carded yarn. For the hosiery fine yarn, we have to go for the combed yarn. And for the shooting and some other application where finer yarn is not needed, then open end yarn and air jet yarn. And some property of this open end and air jet yarn is different to the ring spun yarn, and some properties are also better in the ring spun. The first process is the ginning, where we are separating the fibers from the seeds of the cotton. This is the ginning process. Next is the blow room. The operation, the function of the blow room is the bell opening. removal of contamination particles, dust removal, disentanglement into fiber flocks, and homogenization of the raw material and mixing of various raw materials. Here the blow room will open the fiber, mix the fiber, remove the contamination and remove the dust and disentangle the larger tuft into the smaller tuft of the fiber. These are the some machines, that is the opening machine, mixing machine, cleaning, dust removing equipment and tube pit. Here the bell opener. It is a computerized bell opener. By the computerized programming, it plucks the fibers from the bell and weigh it and supply it to the further zone. This is the some schematic of this bell plucker. Extract material evenly from the bells, open the material gently, open up the smaller flocks. From flocks of equal size, process as many bells as possible in a single charge. So here this is a bell opener, and here you can see there's two roller are there with a certain gap. If this top will not be small, then the gap, it will not pass to the further zone. So this is the bell opener, part of a bell opener, and it is the compartments where the bell opener, the supplies from the bell opener stores here in the vertical compartments. And in the blow room, there is a different course openers are also there. There is different course openers with blades and beaters and suctions are there. Where there is a beating point, there is a suction point to suck the dust particles from the material. And these blades and beaters are different to make it coarse opener and fine opener. So these machines opens and beats the fiber to remove the dust contamination out of the fiber. This is a finer opener by beater, which is a Kirchner beater, and this is a sculpture zone where the lap is forming. Lap is a intermediate product which will be fed to the carding. It is a conventional batch-wise process, and another is the tube feed system where the directly small open fibers will be fed to the carding zone. So that is the direct feeding to the card, that is tube feed system, where again it is one advancement to reduce the energy. So if we'll see what are the advances in the blow room line recently, that is automatic bell opener, compact blow room line, use of beaters in a series for effective cleaning, moat knife with suction and deflector plates in place of grid bar. Moat knife if you will describe. So for the beating, there is under the all the beater there is a grid bar arrangement with a rod-like structure at that on which this fiber will be beat up. And here that has been changed to the moat knife with suction. The moat knives, these are the structure of these bars has been changed with the suction points to suck the contaminant dust from that point and make some efficient cleaning of the fibers. Then multiple beaters instead of single beater. So in the conventional machine, there is a single beater in one compartment. Now people are using multiple beaters to increase the efficiency and compact the blow room line. And automation in removal of contaminants and impurities. That is automation have been also introduced in the blow room line to remove the contaminants and impurities present in the fibers. Then after this blow room, next process is the carding. Function of carding, if we will see, there is removal of dart particles and short fibers. Most of the dust has been removed in the blow room. Whatever the present in the fine dust, it will be removed during this carding. And main important is the short fiber separation. The carding removes the fine dust and dust fragments and short fibers. So individualization of fibers. Here the carding action is, it separates by all the fibers one by one and arrange it in a wave form. Then mix the fibers thoroughly and the drafting and sliver formation. Sliver is the first stage of the yarn shape, and drafting also stretching of the fibers to make it parallel to the axis. It will stretch the fibers then it will be arranged in a parallel form to the axis of this sliver, long length sliver. Then removal of naps and short fibers. So naps means some entangled mass of the fibers present in the fiber. It may be due to the immature present of immature fibers and some entangled formation during the blow room wetting and cleaning. That will be removed here. Otherwise, if these will be present, and it will make the yarn non-uniform, which will reflect in the fabric. Fabric is also not good look. And this is the carding machine. These are the parts. This is the tube feed, the direct feeding from the blow room to the carding. Here some opening Lickerin zone is there. It is the carding and the flat, the same type structure of flats with the wire points. All these cylinders are covered with the wire points, which separates the individual the fiber from the flocks one by one. And this flat is rotates over this cylinder with a very low speed. And again, whatever the short fibers and dust charged to these flats, wire points, and again these wire points when come out, it will be cleaned, and then again the fresh cleaned flats will be come into the action. This action between the cylinder and the flat is the carding action. Most of the action takes place individualization action. Then these individual fibers arranged in the cylinder wire points will be transferred to this buffer wire points. Then it will be condensed, collected here, and it will be condensed to a sliver form. Continuous sliver will be collected in a can, in a container. Then what are the advances in the carding? This is use of multiple Lickerin in place of single. Increase in the carding zone with the width of the card. The card width has been increased, and the carding zone also has been increased by increasing the number of flats in the action. Use of pre and post carding segments. So after this flat and cylinder zone, there is two zone is there, pre and post carding segments. There is also some developments have been done. An integrated grinding system. Grinding means time after some time we need to grind the wire points, because a wire point becomes blunt, so it will not work properly. So there is a grinding system. It is conventionally it was grinded by separately, but now it is an integrated grinding system to reduce the time. And use of auto leveler to make the uniform sliver. Auto leveler which level the sliver thickness. And online flat setting and Lickerin wet setting. Online naps monitoring. Naps can be monitored online, then we can also take action to rectify. And integrated draw frame. Draw frame is directly integrated to the carding, which is the next step of this carding. And individual motor driven with computerized control. And the driving to the different zones, was Lickerin, cylinder, and duffer, which was going from a one motor, so the gear arrangement. Now they have been changed to individual motor driven. This control system is very easy. Next is the combing. Combing is an optional process to make the fine yarn. We are using this combing process to comb there is a combing section which combs the short fibers present in the sliver. If some short fiber is there, this combing section is there in a cylinder, there is some portion is comb is there. Due to the time cycle, when the fiber comes out of the grip point, it combs this fiber from a certain length of fiber and removes the short fiber which is not in grip. So after this removal of the short fiber, the fiber length becomes very uniform, and from that combed sliver, we can prepare a very fine yarn for the hosiery to prepare the fine cloths. You can see here that's carded yarn, and here the combed yarn. Is in a blackboard we have arranged the yarns. There you can see that some slopes and naps are present, and is the combed yarn. If it will be woven into the fabric, this effect will not be the fabric good looking. And here from the comb yarn, we can make some clear and finer fabric. Next step is the draw frame. Draw frame, after the individualization, we have to arrange the fiber parallel to the axis. Such staple fiber will be arranged parallel to the axis and utilize the maximum length of the fiber. it should not be overlap each other. So overlap should be at the end of the fibers. Doubling or multiple sliver and drafting for mixing and homogenizing. So draw frame function. What are the function of draw frame? Doubling. We can use 6 to 8 slivers at a time and draw it to a single sliver. By doubling, we are decreasing the here, we are reducing here the CB percentage, coefficient of variation, and the removal of dust from the slivers, production of homogeneously mixed sliver. If we can blend here also, if we use some black color fiber sliver and white color, we will get effect. Here we can use the 50-50 or as per the requirement, the colored slivers with the white slivers. Then additional control for sliver uniformity. This is the draw frame machine. Here you can see that this is the carded slivers. This is yellow color slivers. It is the 6 slivers are coming to the draw frame zone. Here the roller arrangement is there with the differential speed. The back roller is the rotating at slow speed and front roller is rotating at high speed. So by this speed variation, it stretches out the fibers to make it parallel. And the rollers are covered with the cords, shaft coating over the rollers, and then this drawn sliver being collected here for the next step of the hand spinning. So what are the advances have been made? That auto break draft setting. Break draft means this is the how how much times it is stretching from this roller. This is the draft. So this draft, the back roller and middle roller, this draft is the break draft, which is a small draft. Small stretching is here to upon the residual twist. And the delivery speed is 800 to 1100 meters per minute. Draft range is 4 to 40. Auto leveler, use of auto leveler to increase the uniformity in the sliver, and auto doffing system. Doffing means, and if one can is full, then it will automatically replaced and another empty can will be filled there. Next process is the simplex or speed frame. Speed frame, it is a machine also reduce the diameter of sliver. The sliver diameter, if it is not according to the yarn suitable for the yarn diameter, then we have to intermediate step to reduce the diameter of the sliver to make the suitable for the yarn making. The drafted or attenuation, here also we can apply the draft again stretching and attenuation to improve the parallelization. So this material here is known as roving. So after this so much stretching of the fibers, so that the strength is very low, we can't handle it properly. So we have to apply small twist to give it the strength for the transporting and handling. And a flyer is used to insert the twist, a small twist, and to form a package. Here is the machine. There is also a roller arrangement to draft it, and again is the flyer is that to apply some small twist to this material and it used to make a package over a plastic bobbin. This package will be sent to the ring frame for the spinning, make the yarn. So advances in speed frame. What are the advances now been made in the speed frame? So higher flyer speed using plastic flyer. So if we will reduce the weight of the flyer, the speed can be increased. Auto doffing and auto bobbin transport system. Auto doffing means after a certain length, the bobbin will be automatically replaced with a new empty one, and this bobbin will be automatically transferred to the ring frame section. Then effective stop motions are there, and electronic driving system. Electronic driving, all the movable items are being driven by the individual motors. Blower apparatus. There is a single blower which moves over the machines to remove all the flies near the machine, which are flying near the machine. That's fiber flies. Otherwise, it will contaminate the material or make the nets or slabs. And here there is a computer monitoring device. So there is a digital device is there, human interface. It shows all the data to monitor the performance of the machine. Next is the ring frame. The last stage in the manufacture of yarn spinning is the ring frame. The roving is converted to yarn of the required count. By the drafting, count is the unit to measure the yarn. The drafted roving is then twisted by a ring and traveler arrangement. The amount of twist inserted here is much larger than at any other stage. The twist inserted here is more than it is the required twist which we are applying here. The twisted yarn is then wound on bobbins. Three essential operations here we are performing: drafting, twisting and winding. This is the different zones of the ring frame. This is the ring frame machine. These are the creels which the supply material will be held here, and here is also drafting arrangement, roller arrangement is there to draft again, and here the ring and traveler arrangement is there to apply the twist. This is the front roller delivery where the material is coming, and it is the balloon breaker to shorten the balloon, and here one ring is there over which one traveler is moving and the yarn is passing through the traveler, and the spindle is rotating at high speed, and due to the rotation of the spindle it is dragging the traveler over this ring, and this is the lagging of this distance which is winding over the bobbin, and this rotation applying the twist here. It is the holding point and is the rotation point. The twist is applying here and material is coming here, and the lagging of this difference in the speed of this traveler and the bobbin, the amount of material is winding over this bobbin. This is the mechanism for the application of twist. And this ring and traveler mechanism is a very difficult mechanism where it is also limitation of the ring spin to reduce the to increase the production and make it high speed, because there is heat regeneration is there between the traveler and the ring, and which affects the material, burning of material and damage of ring, end breakages increases. All these limitations by problems arises due to the increase the speed of the machine. The function of ring spinning is the attenuate to rubbing until the required fineness is achieved. Whatever the fineness we need in the yarn, we will achieve here before the application of twist by drafting. To impart the strength to the fiber strand by twisting it. Then we have to apply the twist to make it stronger. To wind up the resulting yarn in form of suitable for storage, transportation and further processing. Here one limitation is the package is very small. Then we have to make it is the bigger package. What are the developments in the ring frame? Recently, automatic roving transfer. So roving will be transferred from the speed frame to the ring frame automatically. Electro drafting system with individual motor. Here all the rollers are individually driven, so we can easily control the speed and set our required draft. To impart the strength to the fiber and strand by twisting it to wind up the resulting yarn in the form of suitable package. So development is automatic roving transfer, electro drafting system with individual motor, orbit ring and SU ring. SU ring, here is the contact point is more, and it is suitable for the synthetic fibers where the optimum heat exchange is there, and it increases the speed of the machine somewhere compared to the conventional traveler. This is the white is the ring and it is the traveler which moves over this ring due to the drag of the yarn by the spindle. And orbit ring is for the blended yarn, and here is also this design is different than the SU. It is also by using this traveler it can increase the speed of the spindle. And auto duffing system, after the required length this bobbin will be automatically duffed and the empty bobbin will be placed at that place, then machine will be started again. Next is after due to the small package, another stage comes winding zone to make the larger package and faultless long yarn. Whatever the fault will be removed here, and it will be large package will be found by this machine known as auto corner. It's a very good machine for this winding, and other machines are there. It is a very short time to discuss everything. After the preparation of yarn, it's passed to the winders for the winding same yarn or big cones for the warping, for the weaving section. Their faults can also be removed to a certain extent with the help of splicers. Here electronic yarn clearer is there in the machine and splicer is there. It clears the fault and again splice without any fault. After winding, cones are passed to the warping section to form the beam. Other yarn spinning techniques are there other than this ring spun, that is open end, compact, friction, air jet and vertex. This is very modern techniques to make the process shorter. Compact spinning is a ring spinning development ring spinning. Here compact spinning, we are decreasing this spinning triangle. Here spinning triangle is more, short fibers are there which creates problem. Here by decreasing the spinning triangle by the arrangement of this roller and suction system which keeps the compact all these short fibers or side fibers and make the compact yarn. Air jet spinning, here we are not using the ring and traveler. Here by the rotation of the air nozzle, where nozzles are there by the rotation which is applying the twist over the yarn. And it is the modern system of the air jet, is vertex spinning. There is a recent development, modern development of this air jet. This is the air jet spinning yarn. This is the vertex spun yarn. Here you can see the wrap fibers are more. In this yarn structure, these core fibers are parallel and surface fibers are wrapped over it. And here the wrap fibers are less in the air jet, and in the vertex wrap fibers are more. It is the development of this air jet spinning system. So another friction spinning is that the spinning is happening, twist is applying due to by the two rotating rollers due to the friction at the nip. And is the rotor spinning, here it is open end spinning. Actually there is the totally fiber is draw from slivers are opening here by the opener. Then by this nabble tube fibers are coming to this high rotated rotor and it is accumulating over this groove of this rotor, and we have to feed a yarn here in the center. It will collect all these fibers and apply the twist, and a yarn will be delivered out of it. So it is also, production is also high, and it is a very short process to prepare the yarn, but some difference in the yarn is there. Count means fine, how fine we can prepare the yarn. In the ring spinning we can up to 120. Finer yarn we can prepare using the ring spinning. Friction only 40 count. It is very coarse yarn. Rotary also 30. Now it is also more than that rotor is possible to prepare. And it is RZ also 50, 70 also people are preparing. And it is coarser yarn is possible by this technology. Tenacity is very good in ring spinning due to the twist. It is average. Rotor is also good with the tenacity is comparatively lower than the ring spun yarn. Evenness is good in ring spinning, and these are in the rotor also very good, and RZ also good evenness due to these wrapper fibers. Hairiness is also high to moderate in hairiness, in more is ring spinning due to the ends, fiber ends. Here is very low due to the moderate in rotor and RZ due to the wrapper fibers. Stiffness is low and it is less than rotor, higher than ring frame, and some yarn quality is different in the modern technology. So ring spun is now in use. No method are there available to obsolete the ring spinning process. Yarn numbering, there is two numbering system is there. One is direct and is indirect. Here the indirect system is English count. That count I was telling, that is the count. Here unit of weight is fixed, and unit of length, how much 840 yards, how much length is present in a fixed weight. That is the indirect system. If it is more, the count is more, it is finer. But in direct, the length unit is fixed, how much weight is present in this length unit. Here if denier or text is more, it is coarser. Then energy consumption in the yarn spinning process, if we will see, that what are the how much energy are consuming in which area. The machine is 78%, compressor 3%, lighting 3%, humidification plant 16%. If we'll separate the machine, what are the different zones? That is blow room 11%, carding 12%, drawing 5%, combing 1%, simplex robbing 7%, ring machine is ring frame 37%, open end is 20%. So main machine and all these sectors we have to work to reduce the energy consumption by changing the technology either, or by changing the material, or by changing the drive system. And here steps to reduce the energy consumption. High speed machines with automations, use of energy efficient spindle oil in ring frame, optimum oil level in the bolster. There is a oil is there in which the spindle rotates, and use of lighter spindle in place of conventional spindle in the ring frame, use of sandwich synthetic tape in the ring frame, optimization of ring diameter respect to count of yarn. We can't use the higher diameter for a certain count. As per the count, we have to change the diameter of the ring frame to reduce the energy consumption. Installation of energy efficient motors, installation of energy efficient axle fans for suction, use of lightweight bobbin in the ring frame, installation of soft starter in motors, installation of variable frequency drive in autocorner winding machines. Again, what are the steps, what are the points we have to see in the air conditioning and humidification system? Use of mist nozzles in air conditioning room, installation of variable frequency drive motors in humidification plant, use of fiber reinforced glass impeller in place of aluminum alloy in case of fans, wherever you are using the fans. So impeller material we have to change. This is all about. I think I could conclude a total all the parts, and it was not possible for me to explain all these things because it is a long process from yarn spinning. And I at last I thank you all for the attention. Thank you.
Thank you, sir.
Yes, sir.
It is very informative, and you have finished exactly at 30. You stick to the time.
Yes, yes.
With wonderful machine diagrams and PPT presentation, I think our participants enjoyed it. Once again, thanks. I request Dr. Shamal sir to say something and give a concluding remark about this lecture. Shamal sir, please.